Good evening, class 11. Let's start. Today we are going to discuss law of mass action. So, the rate of a reaction is proportional to the product of active masses of the reactants, each raised to power equal to their stoichiometric coefficient given in balanced chemical equation. Now, these active masses are the molar concentration of the reactant. So, if I write the reaction A plus B gives product. So, according to law of mass action, I can write the rate of the reaction is proportional to the active masses, that is the concentration of the reactants. Here the stoichiometric coefficients are 1. If I remove this proportional sign, then a constant is placed. Now this K is known as rate constant of the reaction. Okay. Next, we move to derivation of the law of chemical equilibrium. For this, we write a general reversible reaction, that is A plus B reversible C plus D. Okay. Now, applying law of mass action, rate of forward reaction is given by this. Is equal to Kf. Kf means rate constant for forward reaction. Box A and box B, active masses of A and B or molar concentration of A and B. Similarly, rate of backward reaction is rate constant of the backward reaction Kb and molar concentration of C and D. Right? Now, at equilibrium, what happens? Rate of forward reaction is equal to the rate of backward reaction. At equilibrium, this two will be equal. So, Kf box A box B is equals to Kb box C box D. Okay, or I can write this Kf by Kb, means the ratio of the rate constants, equal to the ratio of the concentration of product and reactants. Now this ratio is known as my equilibrium constant, which is given as Kc. Kc means K means equilibrium constant and C with respect to the concentration terms. Okay, so equilibrium constant at a given temperature is the ratio of product of concentration of the reactants to the product of equilibrium constant at a given temperature is the ratio of product of concentration of the products to the product of concentration of the reactants, each raised to power equal to the stoichiometric coefficient given in the balanced chemical equation. Okay, so this is my Kc, which is the ratio of the product concentration to the reactant concentration, which is given as Kc. Now one more term we have, that is my concentration quotient, which is given as Qc. Qc, it is the ratio of product of concentration of product to the product of concentration of reactants, each raised to power equal to the stoichiometric coefficient. Now this Qc is equals to Kc only at equilibrium, means at equilibrium my concentration quotient will be equal to the equilibrium constant. Okay. In case of gaseous reactants and the products, the equilibrium constant can also be expressed in terms of their partial pressure. Now, what is partial pressure? Partial pressure of a gas in a gaseous mixture is a pressure that an individual gas will exert if it occupies the whole volume of the mixture. So, if I write a general reaction, alpha A, then beta B, reversible A, C and B, D. Okay, where this capital A, B, C, D means A, B are my reactants, C, D are my products, and this alpha, beta and small a, small b are the stoichiometric coefficients of the reactants and the products. right? So here if I write the equilibrium constant, now all these substances are gases, A, B, C, D, they are all gases. Okay, so I will be representing the equilibrium constant in terms of their partial pressure. Okay, so my Kp will be the partial pressure of the products divided by partial pressure of the reactants. So this way we will be representing Pc, partial pressure of this one, and raised to the power the stoichiometric coefficient, Pd, Pa alpha, Pb beta. So this is my Kp. Okay, and this representation we can do if the reactants and the products are in the gaseous form. Okay, so that's it, class 11. Thank you.